Good morning. My name is Samriddhi Hisaria and I am here to present the topic optical fiber. My registration number is 20BCE0792. My faculty's name is Bhaskar Sen Gupta and my slot number is C1TC1. Optical fiber. Optical fiber is an optical transmission device which works on the principle of total internal reflection. Fiber optic communication is a method of transmitting information from one place to another by sending pulses of light through an optical fiber. And the light forms an electromagnetic carrier wave that is modulated to carry information. So, an optical fiber is a dielectric waveguide that operates at optical frequencies, and this fiber waveguide is normally cylindrical in form. Principle of optical fiber. So on what principle does the optical fiber basically work? So when we pass a light signal in the optical fiber at a suitable angle, it undergoes multiple total internal reflection along the length of the fiber. Like the suitable angle that has to be more than the critical angle, and finally the light comes out at the other end. So this happens because the refractive index of core is more than that of the cladding, which results in the total internal reflection. Now, what are the components of optical fiber? First of all, the optical fiber consists of the core, that is the glass or the plastic with higher refractive index than that of the cladding, and that portion, that core, helps in carrying the signal. And second is cladding. Cladding is the glass or the plastic with lower refractive index than that of core. And then it is surrounded by buffer. Buffer protects basically the fiber from any damage or moisture. And then the whole thing is there inside a jacket which can hold more than one optical fiber. Now, what are the advantages of optical fiber? Some of the innumerable benefits of the optical fiber is, first of all, it has got immense bandwidth. So we can utilize the immense bandwidth, and total electrical isolation in the transmission medium, very low transmission loss, small size and very light in weight, and high signal security, immunity to interference and crosstalk, and very less power consumption and wide scope of system expansion. Now there are basically two types of optical fiber which are further subdivided. First of all, and we have divided these optical fibers on the basis of their core size. First of all, we have got single mode fiber, and second is the multi-mode fiber. Now single mode fiber has only one type, that is step index. But for multi-mode fiber, we have got two types, that is step index as well as graded index. So as you all can see here, the diagrammatic picture of multi-mode and single mode. Now what is single mode step index fiber? Basically in this what happens, the refractive index of core is maximum and constant throughout the core. And there is a stepwise decrease of refractive index in cladding. But for the core, the refractive index remains same throughout. And the difference between the refractive index and of the core and the cladding is very, very less. And its core diameter is also very small, and it has low attenuation and very high bandwidth. So it has low numerical aperture. So these are used in basically long distance communication. Now for multi-mode step index fiber, the difference between refractive indices of core and cladding is more as compared to that of the single mode step index, and its core diameter is also large. So because of that, several light can enter the multi-mode step index fiber, and which causes modal dispersion. So what is modal dispersion? Basically some modes take longer time to pass through the fiber than the others because they travel a long distance. So it is used in short distance communication because its attenuation is quite large. Next we have got multi-mode graded index fiber. So in this what happens, that the refractive index basically varies from inside the core also. Basically it starts decreasing in the core, and its maximum at the core axis and its minimum at the core cladding boundary. So it's not constant here. The refractive index is not constant in the core. And the index refraction gradually changes across the core. So the modes that travel further also move faster. So this reduces modal dispersion, so the bandwidth is greatly increased. So this is more preferable as compared to multi-mode step index fiber. Now some of the basic terms which we come across while dealing with optical fibers is attenuation. So basically what is attenuation is that it is the loss of signal measured in decibel. And what is dispersion? Basically the blurring of a signal which affects the bandwidth is dispersion. And what is bandwidth? The number of bits per second that can be sent through a data link. And what is numerical aperture? It measures the largest angle of the light that can be accepted into the core. And what is acceptance angle? The basic angle in which external light rays may strike air or glass interference and still propagate down the fiber. Thank you so much. I hope you all understood whatever I wanted to exhibit.